Hello, welcome back. So this is part 2 of Get Started Ethereum Smart Contract Programming using Brownie and Ganache. So in the last episode, we see a beginner-friendly introduction to Ethereum Smart Contract Programming using Solidity featuring Brownie and Ganache. And Ganache, if you recall, helps you spin up a local Ethereum blockchain, while Brownie's Smart Contract Toolkit that we use, it's a toolkit for Python programmers looking to develop smart contract using the productive tools that it provides or the facilities that it provides. Okay, so all of this code is already in my GitHub. But today we're gonna continue on. We're gonna look at the part 2 of this series. So before we start creating another contract, right now on my screen is Visual Studio Code. We already have all the things set up from the last episode. But before we go ahead and create another contract, so today what we're gonna do is we're gonna create coin.sol. But before we do that, let's maybe quickly review a little bit about what we learned and make sure that those concepts are still there. So let's go into the file, going back to simple storage as well. I'm gonna close this out, close that out as well. So this is it. I'm gonna hide the bars so we have a little bit more space to work with. Okay, so we've written this code in the previous episode, and we deployed that into a local Ganache. Now let's take a look at this and let's do a quick revision. Now the first line here, SPDX license identifier. Now that actually is, this is a convention. This is really not Solidity code per se. But if you read the official docs, what it says is trust and smart contracts can be better established if the source code is available, and making source code available always, always touches on legal problems. And since, in a blockchain world, trust is always going to be a main feature of this, right? The decentralized movement. So making source code available always touches on legal problem with regards to copyright. So the Solidity compiler actually encourages the use of machine readable, machine readable SPDX license identifier. So very commonly I use GPL 3.0. You've probably also seen MIT. These are very common examples of that. And again, you can see a full list of that. Look up the documentation, and that's what the first line is doing. The second line, pragma Solidity above greater equal 0.422 and then below 0.9. Now pragma, every time you see pragma, it's actually instructions for the compiler. So you're telling the compiler how to trade the source code. How do you trade the source code that that it has to compile this into some sort of code that the EVM, the Ethereum virtual machine, can run, can be run on the EVM, the Ethereum virtual machine. So this is telling the compiler what to do with it. And here is saying that this works on Solidity between version 0.422 but not to 0.90, because this is not greater equal. So this is only up to 0.9.0. So right now, as of speaking, we have 0.8.12. That's fine because this is still below 0.9. Okay. Then we use this contract keyword, right? What is a contract? Now, contract in the sense of Solidity is actually it's a collection of code and methods. Basically a code, this one, the methods, and states, which is this one. So we create a variable. This is the state of the contract. This is the methods of the contract. It's a collection of that. They put them together at a specific location, at a specific address on the blockchain, on the Ethereum blockchain. So all of this, when you see a contract, it have to reside somewhere on the blockchain. So contract is that collection, and it's when you deploy that, it's gonna be given an address. So the address is how you identify this contract, and you do something with it. And other people can write contracts, they interact with your contracts, and that's how they find you, right? So a contract basically, it bundles together all of this, group together all this, method, the functionalities, the state, the variables, all of it, and it put them. Think of it like just a place that resides on the blockchain, a location on the blockchain, and later on when you deploy that, you're gonna be given a address. That's the contract address. Okay, so that's what it's doing. And then the next line, this unsigned integer 256. Okay, that's basically creating a variable. You're creating a let me write this down here. So you're actually declaring a state variable called stored data of the type unsigned integer. Okay, so usually you don't want to type the whole thing up. You should say uint. Okay, and of how many bits? 256 bits. Right, so that's what it's doing. So the way you think about that is think of it as a single slot in the database that you can later query, and other contracts can query if you make this a public facing variable. So if you make this public, then other variables, other contracts can query it. For now, just gonna keep it like that. We're gonna go into all of that details later in a later time, but right now, just unsigned integer 256, and you name the variable what's data, and that's all you need to do, because then you can then interact with this variable, right? So think of it as just a single slot in the database where you can query, you can alter like this, set, change the values of that, and you can do that by calling functions of the code that manages this database, which is just whatever is in here. So you can have as many variables as you want. You can have another one, this one you can have it as 256 as well, and now you can have some other variables. Okay, and so I think what would be helpful is for us to go and take a look at some of this different variables, talk a little bit about maybe the types and stuff. So we're going to talk about that later, but for now, this is what we're doing up to this point. Okay, and constructor is what we explained in the last video, where constructor is something that initializes. When it's initialized, what do you want to do first? So this is probably a good time to introduce things like setting variables, declaring variables and stuff. So when the contract is first initialized, when it's first deployed onto a blockchain, what do you want to do with it? And here what we're doing is that we said when you first deployed, set the default value onto something. You may think that, hey, we could have just done this, right? And that is something we're gonna get into as well. So for now, just this is kind of really a quick starter guide, just a quick way to show you how a contract looks like, explain a little bit about the components that make up a contract, and soon enough we go into all those like default values and all of these different examples. And then we have the methods in here. So we have we define two methods in here, okay, two functions. So the first function is called the set function, then the other one is get function. And in here, the set function, it takes one argument, while the get function really doesn't take any argument, because it's just all it does is just return the value of stored data, whatever stored data would be, right? And we also see in the last video where we could do something where it looks like this, right? We say simple storage. We go ahead and deploy that. We need a from, we need an account, all of this. But once we've done that, we can go ahead and we did something like get, and we could get the value, and we can do something like set, and we can set the value. So you can try and go ahead and say set 5, and then try and do a get method on it, and call get on it. You see the value of 5 being returned to you. So that's all nice and good. So what we're going to talk about today, I said we're going to actually go create a new contract. But before we do that, I thought maybe just probably more give you a bit more about what Solidity is, and a bit more background would probably help. So I wanted to maybe just take some time and I'll walk through all of this revision, and then now let's go ahead and see what are some examples of, let's say, types, data types, and maybe apart from unsigned integer, right? So let's go ahead and say create a simple another variable. So let's declare another variable, and we're gonna call this a unlock. Okay, let's just call it another variable. Let's just create another variable called unlock. Don't know what it means, but for now, that'll be good. This is good enough. And what unlock would be is it can take a value of true or false. Now, if you're familiar with any other programming language, you're probably thinking that, hey, this is the case for a Boolean, right? You think about Python, for example, JavaScript, you see a true, false, that's a Boolean. So how would you go ahead and do this? Well, one way you can do that, you know that the variable is going to be called unlock. So let's just put a quotation mark around that. It's going to be named that. So you know that this is the type of that, and you know that this is going to be called unlock. And probably this time, well, let's also say default to false, because it's probably a good time to also talk about default values, right? So let's create one, and we say unlock. What do we want to put in front of this? Now, I just told you that here, this is the state, this is the type that you want for this variable. So here, I'm giving you a big hint here that this looks like a Boolean. So what do you think this would be? This would actually just be bool. So Boolean unlock, and that's it. That is how you create another, that's how you declare another variable. And now you can use this somewhere. So you can say something like, once you set that, you can go ahead and maybe here, when you get into the function, you can go ahead and say, set the Boolean to be lock, for example. But we haven't finished the assignment up here because it says it needs to be defaulted to false. So you may think, oh, can I just go in here and just do a bool and stuff? Well, the way to do this, the most straightforward way to do this is to actually just set up to be false, like that. So now you declare another variable, and that would just be called false, right? And so you can have multiple variables. Some of them you can have default values if you want to. You can have, and this without the default value, it just be 0. Okay, and there are, I mean, this is unsigned integer. So what about integer? What about signed integer? Well, signed integer would just be int. Okay, so the difference between unsigned integer and signed integer is that the signed integer itself, there is a sign. It can be a negative value or a positive value. It can be -3, it can be +3, and unsigned integer, basically they just within the variable itself, it doesn't have that. It's unsigned in a way, so you don't have the plus or minus. So it's gonna have to be positive numbers. Okay, so that's kind of the main difference in here. We're probably not gonna have to worry about signed integer too much, but let's just write it out anyway. Let's just say that. Let's create a let's give it a name here as well. We're gonna call it counts. Okay, let's say this default to 0. Let's say 5. Okay, and so that's that. But what is more common is another type, address. Okay, so this is also pretty common, is that you would have a type of address. And types of address, this is interesting because this is a built-in type as well. So you can write something like address, and you can write, let's say this is simple storage. You want to say there is a storage owner, for example. So you want to have a storage owner, and here you can pass in the address, and the address would typically look like something like 0x and then some other random numbers, just a bunch of the, this is the hexadecimal digits that represent that. So you can pass in a, this is my address. I'm using it for testnet anyway. I'm not really having I don't have any assets in here anyway. So this is just kind of my address, but you can, if you want to, you can just go and, create a new account using MetaMask or whatever, and then just paste your address in here. So that's kind of another kind of type that is already built into Solidity. So you can have address, and address in here is saying that this is a type of address. So if you want to set an address later on, you're probably going to have a set function like that. You're going to say change owner. So this is storage owner, right? So you can have something like change owner. Change owner. And here, no, this is not going to be unsigned integer anymore because you want to take in an address. So you want to be the new owner. And then you want to just have the storage owner be set to that. Okay, so we're just going to make this lowercase right now, and you can then change storage owner, and you can set this to the this variable that you take in, and put a semicolon in there. So obviously this is not a very good way of writing it, because you allow anyone on the blockchain to call this method and change the owner to someone else. So right now the owner is us because this is my address on the blockchain, but it allows somebody to just call this method, change owner, pass in a value, and now that will be changed. So that's gonna be somewhat of a problem. So how do we make sure that some of these methods can only be called, let's say by the owner himself or herself, or you can, maybe change some of this method to be, instead of being public, it can be private, or it can be, there's so many other ways to, to work with that, and that's something that we're gonna get into as well. And probably the last thing here you see is bytes. You can also set a bytes. You can say bytes XYZ. It doesn't really matter what it is, and you can set a value. You can say this is like I think 5F. Do you want the bytes to be somewhere like 10 bytes or 1? It's up to you, but you just need to set what it is, and it goes all the way. If you try and look at the autocomplete, it goes all the way up to 32, right? Okay, if this is something like a, and this is 1 byte. Why? Because 5F would translate to a number, for example, like like 10, something like that, right? So 1 byte, and I'm not gonna go too much into details for that, but right now this is how you set a bytes, and you can have other stuff. You can set byte 64, and bytes 32, for example, and you say ABC. And that's how you create another one. You can have more if you want to, right? For now, that's it's probably good enough for us. We don't really need to worry about that. And for the most part, I think what you really need to worry about is really just this you know, the unsigned integer, the boolean, the integer, the address. And if you're not really sure, then you know, you can always stick to unsigned integer for most of the numeric. You can always stick to boolean for the for you know, true false values, address for that. We haven't really talked about the more complex one. There are things like what about mappings and stuff, but we'll talk about that later. So another idea I want to talk to you about, also relating to the variables itself, is the fact that the variables up here, all of this, they are state variables. So what are state variables? Now, state variables are declared outside of a function. So if there are functions, this is also we can have a variable in here, local. We can set another variable in here, so we can have something like I don't know, integer. What do we want? 256, and we can say this is a. We already have a count, so I don't want to use the same thing, but I could say counter, I guess, or counter 2, right, or whatever, counter, right. Let's go ahead and just say counter plus plus. Okay. So what we want to do instead is to just say that every time we do that, you know, just add a counter and stuff. So and this is completely meaningless. I'm doing this to show you what are the different ways, you know, in terms of variables and stuff, right? Now, what you see up here, the stored data, unlock, count, storage owner, and XYZ, that's state variables. So state variables are declared outside of a function. So all of these are declared outside of a function, and they are also stored on the blockchain. Okay, they're stored on the blockchain. So if you were to access this contract and using your Ganache, which we see how to, you know, in the earlier video, in the previous video, you see how to do that. These values, you can access them, you can get them, you can access them, you can see them as long as they're public, and anyone can query your contract and get the values of that. So it's actually stored on the blockchain, and that's going to incur some, we call it gas, okay, incur some cost. Local variables like this, now that's declared inside a function. So because it's declared inside a function, it's not really stored on the blockchain, it's not really a state. So this here, up here, that's a state variable, and this is what we call a local variable, okay? And there is another third concept called a global variable. And global variable are things, for example, where if you were to take that and you can, let's say instead of using new owner, we could go ahead and maybe set a sign, no? So, and let's not make this a public, let's make this an address, okay? So you want to say that who is calling this function and what does it do and stuff. So it says it's unused right now, so let's do something with it. So let's say that, okay, once you set it to a new owner, we want to actually modify this value and say assigner is the message.sender. So what this is basically the address of the caller. This caller could be another contract, it could be, you know, another user, it could be, you know, or anything. So if somebody calls this function to change the owner, we want to save that and we want to say who actually, you know, called that function to change that. So message.sender, realize that this is not actually in the argument that we take, but this itself, this is a global variable, right? So message.sender is a global variable because it's there, it's just available to us. This is information that is already on the blockchain. So every time there is a transaction that makes a call to this and change owner, call this method, there is some information, there are some there are some variables that is being created. This is one of them, okay? Let's create another one. Let's call it unsigned integer. Actually, we can also have the same thing. Actually, let's just keep it unsigned integer. Let's just make it quick. And here we're gonna just say that this is a timestamp of this happened, right? So time of change. Okay. Every time this happens, we want to change the assigner, but we also want to go ahead and do something like take this value and take time of change and want to set that to something. What do we want to set here? We want to just set that as a when the let's say block.timestamp. See? So in this case, this is another global variable. Just another global variable that is already on the blockchain. So again, there are some of these different variables that we talk about that you're going to see more and more throughout the series. But for now, these are ways you can create. These are all local variables. Okay, so these are all local variables. Compared to the one above, all of this are state variables. And you should know that because we been explaining the concept, and also you see that declare a state variable. So that's what it's doing. Okay. But let's say storage owner. Let's say we really don't want anyone to be changing storage owner. We really want this to actually be, you know, a fixed value, because we are the contract owner. We created the contract, and we just somehow we don't want people to be able to modify the value. So what do we do? Now it turns out there's an idea in here where we can just say this is a constant. When you say this is a constant, now the compiler is going to give you a squiggly line here saying that you cannot assign value to a constant variable. So he's saying that, hey, if this is a constant, then nobody should be able to modify that, because this is no longer a variable. This is a constant. So this is a constant. It's a hard-coded value that cannot be modified. Cannot be modified because it is a constant. So you can also do that, and now this value cannot be changed, you know, from any of these internal functions anymore, or from external functions. Same thing, right? So let's change that away, move that out. But now this whole thing doesn't make sense because you're only using new owner, but it says that it's not actually being used. This is an unused function parameter, so it actually throws an error. It says, why are you taking new owner but not using it anywhere? It's not being used anywhere. All right, so this is something that we want to just take away. So all of these are just you know, code to explain you know what's happening in here, to give you some sense of, you know, how the Solidity works as a whole. And very closely related to constants is this idea called immutable. So what is the difference between constant and immutable? So you may also see immutable. Well, the difference between constant and immutable is that values of immutable variables, they can be set inside the constructor, but they cannot be modified afterwards. So for example, in our constructor, we can go ahead and change that. We can say, okay, now storage owner is a new value, and let's put in a new value here. So, and let's remove this like that. So now this is the you know, an immutable. And so immutable kind of acts like a constant, except it allows you to set this value within the constructor. So within this function, the constructor, which is when it first initialized, but it cannot be modified afterwards. So if you try and do something like this, and you then change the storage owner and change it to some other values, now that's going to be an issue. Okay, that's going to be an issue because it's immutable. You're not supposed to be able to change that. Okay, so so if you do that now, you're probably gonna get a complaint. It says that you cannot write to immutable here. Immutable variables can only be initialized, inline, or assigned directly in the constructor. So that's also a concept that you may come across. You know, so immutable basically means you can set that in the constructor but not modify it afterwards. And so if you want to do that, you can. But let's just maybe keep things simple and let's go back to the constants because we just want to keep it like that, constant. So that's immutable for you, right? Now, one thing that we've actually alluded to in the last video was that we talk about the view function. We said that if you do a view, you're making a promise that, hey, I'm not going to change, I'm not going to modify any of these variables. I'm not going to modify the values of any of these variables. I'm not going to change the value of count. I'm not going to change the value of storage owner. I'm not going to change the value of XYZ. And so when you do a view, that's basically you can read this state variable without actually having to send a transaction, meaning you don't have to pay any gas fee. It's actually free. But if you want to change the value like this is actually going to require you to send a transaction. And when you send a transaction, you can write to any of these variables. So you can alter the value from 5 to 6, from 5 to 4. You can alter the value of storage owner from this to another value on another address. But when you do a set, you are actually paying a small transaction fee. We call it as gas, and we haven't talked about gas yet in more details, but you have to pay some amount in order to modify the value in here. So if you want to read state variables, you can do that for free without transaction fee. But if you want to write to a state variable, you then would be required to actually write a transaction to make a transaction and pay a little bit of a gas fee. And this gas fee, you will see them being you will see them in this currency called the Ether currency or the Way currency. So this will incur some transaction fee. Actually, let's put this up here. Oops. Okay, so let's say this will incur a transaction fee. And because we're doing this on Ethereum, the currency in Ether, and even in Ether itself, because Ether itself is you can kind of like how you have $1 and $1 is 100 cents, right? In Ether itself, you will also see this in way. 1 Ether is 10 to the power of 8, so 1e18. Either 1e18 or you can say 10 to the power of 18. Okay, so 10 to the power of 18 way, meaning 1 and then 0, 0, 0 all the way. So 1 Ether equals to 10 to the power of 18 way. So usually in Python we can just do a 1e18, so probably cleaner like that. So 1 and then e stands for the exponent and e18, right? So that's kind of that's the way we work with you know, a transaction. So when you want to transfer some amount of you want to transfer some value from this wallet to another wallet, or you want to maybe pay towards this contract, or you want to, let's say, raise fund on donation or whatever it is, you know, what have you, that's going to be done in this currency called Ether. So you're going to hear like 1 Ether, you're going to hear Wei, another one is Gui, but you know, probably for now don't want to confuse you too much. But you're gonna use Wei or Ether to pay for gas, or to, you know, make a transaction, or to maybe make a transfer, or to make a donation, whatever that is, right? So and depending on how complex the function is, trying to run functions as well, that is also gonna cost a little bit of a gas fee. Okay, so that's also something that you wanna just keep in mind of. Now, one other thing about you know, creating this kind of variables. So one other thing you come across is this idea called mapping. So mapping is kind of if you work with Python or you work with JavaScript, you probably look at objects. So you look at for Python, it'd be something like dictionary, right? So mappings is created as a way for you to map certain key to certain value. So if you think about key and value in JavaScript or ES6, for example, or TypeScript, you probably heard of like using objects to do that, right? You say that, hey, if this is the key, find me the value, the corresponding value to any key. And in Python, you probably have something like a dictionary. So dictionary, again, is just a fancy way of saying a key value pair, right? There's a key, there's value. And the key itself could be, you know, something like a, you know, it could be a string, it could be a integer, it could be anything like that. Now in Solidity, we work with that using this idea called mapping. So let's say we want to have a mapping. This is a simple storage. So we want to have people actually store something. Let's say you can store their values in it. Let's say they can store more Ethereum in it. They can store their NFTs, you know, in our contract, whatever it is. So you want a way to map certain accounts. So you want to be able to map, for example, you want to be able to map Adam's account into some sort of NFT address, right? So some NFT address, it doesn't really exist now, but let's just imagine that. And Adam also, it needs to be an address. So here we have Adam's address, and we have Eve, again, address. And we have Charlie, again, his address. So in a way, what you're trying to do here is that you want to be able to create some sort of a data structure that maps one address, which is the user address, to some sort of NFT addresses. Okay, now what you have here is a mapping, because now you can do this. You can say mapping, and you can say map from an address to another address. And this will just be a public variable because anyone can query that, and you can just call ownership if you want to. So this is a way for you to create a mapping, and now anyone who query, let's say if I put in Adam's address in here, I will get Adam's NFT address value returned back to me. So this is kind of a mapping. Okay, it's just a key value store. If you put the key, you get a value back. Another way to look at mapping is we can have something like mapping. Let's say we want to store. Again, let's say we want to store. These are all pseudocode, by the way. This is probably more not Solidity code, but just to illustrate the idea, right? So I want to have Sam. And now I want to give him an account balance. I want to say every time you store something, I'm going to give you some credits. And the credits would be something like, you know, let's say 100. And I want to have, again, I want to have Adam. And if he stores something, I'm going to give him some credits. And again, he accumulated 35 credits. If, you know, and again, give 75, 76, so on and so forth. Now, I want to create this kind of mapping. I want to say that every time somebody deposits some items, I want to give some credits, and this credit will always be positive. They're never going to be negative. I'm never going to take away the the user's credit. The worst you can go to is 0. So what would this be? Would this be an unsigned integer? Well, because we really never go below 0, we can just use an unsigned integer. So from here we can just say mapping, and this is going to be an address, right? So we're going to say that if I query for Sam's address, and let's say this is Sam's address, so I'm just going to copy that. I want the value 100 being returned to me. Okay, if I put in a different address, well, this is not a valid address, but let's say I put in that address, I want to get 35 back returned to me. So because of that, I'm gonna have the key being an address type. So that is basically the key type. Okay, the type of the key itself. So the key is the address, and what do I want? I want it to return what? To return a value, and I just said that the value can never be negative, so it's gonna just be an unsigned integer. So let's just do that. Let's unsigned integer. You can have 256 if you want. That's how many how many bytes, how many bits you want to give it. So 256 means 256 bits. 8 bits to a byte, so you want to do the math there. But you can now give it a name, and this is going to be public. This is credits. How many how many store credits? Okay, so this allows us to query by passing in the key, and we should be able to get a value. So let me just show you how it looks like. Okay, so let's say query credits. Okay, when you do a query credits, what do you need? You need basically the address in here. So let's go ahead and say if you do that, you need an address. And what do you want to call this? You can give it underscore key address ADDR. Okay. This is going to be a public one because anyone can use it. It's going to be a view because I'm not going to change any of this value. So it's going to be a free function for us. When you do a view, again, it doesn't cost any gas fee. So let's do that because we're not modifying the value. We're just trying to return, from this mapping. So we're going to just return. Now, what do you want to return here? Now, this is unsigned integer 256, right? So let's go ahead and do that. Unsigned integer 256. So you have query credits. You're actually going to pass in, when you call this function, you're going to pass in a key address. You're going to receive this. Okay. So let's go ahead and say return what? Return from the store credits. And this is how you basically return that. You say return key address. Semicolon. That's it. So this allows anyone to be able to say, hey, if I call query credits, I need to pass in one item. What is that thing? That's basically the address. And it will then map it to the key and say, okay, what is the corresponding value? Oh, just return that value then, right? So you can do that. And that's kind of how you sort of query for that value. Of course, you can also set the value. So if you want to set the value, you can do that, and you can say, well, when you do this, you can also then put in store credits. Whoops, yeah, I spelled it correctly here. And then you want to, maybe take another parameter here. You want to take an address, and you want to call this set address, or you want to call this the caller address, for example. All right, so you can do that. Or in this case, we can just do a message.sender. And we can just pass in the value, and we can say pass in equals I don't know, we can just add 1, I guess, just maybe give him 1 credit. But ideally you probably want to set this value to be something that makes sense. In this case, I guess we give it a credit divided by 10 of this, so we can say just plus equals, and then we say x divided by 10. Alright, so you're saying that if this guy is actually storing 100 worth of goods, 100 whatever currency worth of goods, we want to give it 10 credits, or so on and so forth. So that's how you want to, this is up to you to when you create the smart contract, you probably want to think clearly about that. Right now, you're just talking about syntax, so it really doesn't matter right now. But that's how you would create this kind of mapping. And that's kind of where you need to know now, because once you have all of this basic knowledge, we're good enough to actually get started with writing our second contract. That's going to be the coin contract. So let's get started. So if you haven't done that already, go ahead and click on, let me just delete that and start from scratch, right? So you're just going to delete the coin contract, you're going to say move to trash. So now in your contracts folder, there should be one simple storage.sol. This is the extension for Solidity. So what we need to do is to just go ahead and say new file. You can do that. You can also use your touch. So just say touch and you say contracts, and you just have to put a coin.sol/coin.sol. Okay, do the same thing here, coin.sol. And then once you go back in here, you can just Control P and just type coin.sol and do that. And then you open up, close the sidebar. So now you have coin.sol. So again, what's the first thing we want to do all the time? We always want to create the license identifier. That should always be your first line. Okay, so let's go ahead and do that. SPDX license identifier, and here you can have GPL 3.0, you can have MIT, you can look for other kind of license identifiers up there. And Pragma, we can just have this Solidity, and again you want to support what do we have up here? Just probably going to use the same one, like this. Just going to copy that. Whoops. Copy, save, and just want to copy this one here, paste it in here. And let's start writing our contract. So to start with, let's have the keyword contract. And what do you want to name it? So again, I can name it coin. So I want to just maybe have coin as well in here. And this is going to be the contract. Okay, the contract name will be just coin. And maybe the first thing we want to have is an address. We want to stick in an address because somebody needs to create this coin, right? It has to exist somewhere. So how do we do this? Well, we can call this an owner if you want to. So you can say something like address, public, and you can call it owner. So what this is doing is saying that create a variable called owner, and that owner would just be the that's just going to be the address. This is going to be your address, your address, because you're the creator of this. Now, how do you set that? You can go ahead and say constructor, and just to remind you, what is a constructor? Constructor, all the code that is in constructor, that's only going to be run. That's only going to be run once when the contract is created. Okay, so here we're going to just say owner equals to message.sender. So this is a very common paradigm in a way. What you're seeing here is saying that when this contract got called, the guy who called this contract, that's going to be the owner, the creator of this. You can call this creator if you want to. Actually, it's also quite common to call this a minter. So whoever is doing the minting, and this is also a very common terminology that you hear, but it's the same idea here. So basically saying that when the contract first initialized, whoever initialized that, right, we want that guy to be the owner, and we want to store that into a state variable. So remember, this is a state variable, okay? So no one can modify the value because it's only going to be called once. So if you want to, this is a good time to then think about, okay, can I actually pass this as a constant? But if you pass a constant, you can do that. So what is the other thing that you just learned, right? So pause, think about that. Immutability, immutable, right? So so this is a constructor, and let's go ahead and also create a simple mapping. So you want to actually track who owns how much of the coin, this coin. And so let's go ahead and do a mapping. And this is kind of the same idea as we talked about before. We're going to say address, and we're going to say unsigned integer. You can have 256 if you want. If you don't want to have that, you can just be less strict and just say unsigned integer. Okay, and just say public. And this is basically the balance. So we want to call it balance. So what this is doing is saying that it's a mapping. If I pass in the balances, and I pass in some sort of address, then I should expect this to return an unsigned integer value. Okay. So if I pass this key, I should expect the function or the method to return an unsigned integer value. Okay, because of the mapping. Right. So far so good. Address mapping. Now, you also want to be able to say that, hey, as an owner, I should be able to give people or anyone on the blockchain some amount of this coin that I just created, because you just created a coin, remember? And what good is being an owner if you can't actually give coins to other people? So let's create something called a main function. Okay, so let's create a main function, and it's gonna take the receiver. So who is gonna be receiving that the coin, right? So you say address receiver. And we're gonna pass in an unsigned integer amount, and let's give it an underscore, just to be more clear that it's gonna be a private. It's just gonna be a a function variable here. It's gonna exist within the scope of this function, and we also gonna pass in an amount in here. And again, this is gonna be a public function. But what we're gonna do is we're gonna say that this function, this should only be called by the owner of this coin. So whoever is the creator of this coin, instead of the owner, let's say creator of this coin. But if we can pass this check, if it is the creator of this coin, what do we want to do? We want to say, give this guy the ability to manipulate the balances and to change the balances so that we can add some amount here. And whatever it is that we pass in here, just going to be added to that guy, to the receiver's balance. So how do we put this in logic? So we say balances, and we say take that, receiver, take that, and what do we want? We want to add equals to amount. Okay, so what this is saying, if this is getting a little bit tedious, let's just visualize it a little bit. So I want you to imagine this. Okay, I want you to imagine, like, let's say we have an account balance. We have this is balances, right? And let's say it's just something like this. We have account A. Let's put in some fake address, AA21. Okay, I know this is not a complete address, but let's just to illustrate the whole the whole idea here. Let's say the account actually have 0 balance, and let's also have a few others. So I'm just gonna copy that. Change this figure. Okay. Okay. So let's say this is balances. And what you're wanting to do is you want to be able to say, hey, if I call this method, providing that you check that the guy who created this who called this function is the creator itself, then what you want is to be able to manipulate the value. So you say if I call min and I pass in 0x2de3 and I pass in the value of 15, then I want this to manipulate balances, and now balance should be something like 18 here, right? So what you're saying is that if I call this and I pass this in, pass the value 15 in, it should take 15 at the existing balance. The existing balance is going to be 3. Now you add 15 to it, you get 18. So now this new balance will look like that. So that's kind of what you're trying to do here, okay? But how do we account for this logic, saying that this should only be called by the creator of this coin? But because this would be a terrible idea to implement, because everyone is just going to call this min function, right? So how do you say that, hey, no, I want to make sure that I check for this first, so that only the owner get to call that. So in Solidity, one way we can do that is to put a require, and you say require that the message sender, whoever is calling, message sender is basically whoever is calling this function. So whoever is calling this contract function, whoever is making this transaction call to the contract, that's the message sender. We're gonna say check that that is equal to our minter. This is our owner, remember? So we can just have this, and this is gonna first do a check and say, hey, look, if you're not the owner of the contract, and the owner of the contract is only gonna be set once, which is here, and you can add an immutable if you want. But if that is the case, then you're not gonna pass this, and you won't be able to move forward. Okay, so this is if you want to add immutable here, you just want to make sure that no one ever could change this, right? So immutable, so it's only going to be called in the constructor once, and there you go. That's the min function. Now this also is a time to think about what else do you want in a coin that you just created. And this is a coin you created. You already have the min function, so you can create this coin, you can min it, but the coin is going to be kind of useless if there are no methods for folks to be, let's say, sending, transacting with this coin. So you want actually, you want to have people actually being able to transact in that coin, being able to send this coin, some of this coin that you just created, to some other people, or receive coins from some other people. So you want to have a way to actually take this, transact with this coin. And so let's go ahead and create that. Think about how you want to, implement this. So for example, we could go ahead and say function, and we say send. And what are we going to take? We're going to take 2 things. Well, you can say we may have to take 3 things. We have to take the address of the sender, what do you want to send, and you say address, receiver. You want to put a space between them, and you want to put, again, an unsigned integer amount. But let me remind you that you can actually use the message.sender, and this is the global variable that we've been talking about. So you don't actually need to have this. You don't actually need the contract to this function to take in 3 arguments. You can actually get by with just 2 of them. So receiver and the amount, because you would always have the message.sender available to you anyway, right? So you don't need that, and let's make it a public function. So everyone can call on the blockchain. Everyone can call this function on the blockchain. And what we want to do next is we want to. This is kind of the time where you think about how do you want to first do this? How do you want to actually implement this logic? Okay, so I would say like a good place to start to think about is to first check that the sender does indeed have the amount specified. Because if somebody wants to send 50, but his balance, which is up here in this balances, if it doesn't have that, it doesn't even have 50, you probably don't want to actually allow that to happen, right? So you want to probably do a require again. And what do you want to require here? You want to require that balances message.sender. You want to have that being what? Being at least greater equal to the amount. Okay, you can do it this way, or you can do it another way. You can do it like, you can do the if else. You can say the if, you can say if the balances of message sender is actually lesser than the amount. So that means it doesn't actually have enough of that. What do you want to do? You can go in here and you can say just do a revert. You can say revert, and you can pass in a revert function in here. We haven't really gone into all of this stuff here, but you can essentially just revert and say, okay, this doesn't work because you don't have that. Okay, we'll talk about that later. We're just going to stick to a require right now. And then what we can do next is we can just go ahead and say, okay, if this works though, right? If this works, then we go ahead and just basically call the transaction function, this transaction. And this can be another function if you want to. It can also just be the same function, right? So in our case here, we're just going to say this alternative, and we'll do that later. But for now, let's just say if it works, because if it doesn't, it wouldn't even get to this point. So if this test passed, then go into the next one. So you say take that and take the message.sender, so whoever it is, minus the balance, minus the amount that you want to send. And then the amount is gonna have to be underscore here. And then what else? You want to say, once you've done that, you want to take the receiver. And now you want to add the amount. Okay? And that's it. That's kind of let's put an underscore here as well. That's your transaction. So now I want you to think about, we said there's an alternative in here. So if you don't want to use require, what else do you want to do? What else can you do here? So we talk about the doing the check, the if check. So why don't we let's try that as well. So we can just do an if. We say that if the balances message.sender, if this is lesser than the amount, what do you want to do? You want to just throw a revert. So throwing a revert is kind of saying like, oh, this doesn't work, you can't even pass. Okay, so let's just say revert. And within revert, what do we want to have? We can have an error. And so this is a time where you can introduce some sort of error function. I would just put them maybe up here. You can call an error, and this error is going to be called insufficient balance. And insufficient balance, we're going to throw we're going to throw 2 values. We're going to just take 2 values here. So first of all is basically your unsigned integer 256. That's basically what you requested. And what you want is your balance available. Okay. So you created an error in here, and you say that that error takes the name of insufficient balance, and it should basically have the requested. So this is what you request, and balance available. So you're saying that, hey, you can't do this because your balance available is only this amount, right? So let's put this in here, and let's go ahead and say revert insufficient balance. And within this, we said requested would be this amount. So let's put this in here, copy that, paste it in here, and balance available balance available is going to be from this balances message sender. So you're just going to copy that as well and put this in here. And then, of course, you don't want to miss out the semicolon. So we've done that. So this is another way to do that, okay? Is to say that, hey, I want to throw an error. I don't just want to check for a require. I want to actually throw an error. And the error should say something like error insufficient balance. And then you should take two arguments here. First is the requested. Second is the balance available. So you said, hey, you're asking to transact $60, but you don't have $60. You only have 59 coins, right? So in this case here, you don't allow the send to happen. And this whole transaction will revert. So as if nothing happened, okay? So this is kind of the way you would go about creating a contract. I would say maybe the one last thing you want to talk about, at least for this video itself, is this idea of sending this, emitting a message. It's kind of like logging something, right? So in Solidity, the other concept that you may come across later on is this thing called the event. So event allowed the clients, whatever you're using it with, if you're using Brownie, if you whatever it is you're using, right, allows you to react to a specific contract changes. So every time you make one of the changes in here, for example, you want to emit something, you want to log that out. So kind of thinking, you know, in a way, it's allow people to subscribe to the event and watch for changes. So that's kind of the paradigm here. So I can do that by using the keyword event, and I want to say that every time there's a transaction that happens, I want to call a send event. And in this, I want to put in address. I want to say address from, address to, and I want to log out the answer integer amount. This is a 256. Let's do that. So this is saying that every time, if we watch for balances, for example, every time this happen, every time a modification on this happen, emit this event. So how do you emit an event? You use the event and use the emit keyword. So emit event would happen in here. So after these transactions have been done, you want to say emit an event, and that would be the name of the event. What do we call it? We call it send. So let's go ahead and put send. And what do we have here? Message sender, because it takes from, to, and amount in that order. So they have to be in the right order. So first of all, from, to, so that's the receiver, and amount. So that will be in the right order, okay? So want to make sure you don't mess up the order here. It says here, first is from, and then to, and then amount. So this is gonna just log that out, and people can subscribe to that event. And that is a good way of trying to allow the client, the front end, to react to this, changes that you want to listen to. In this case here, you want to listen to any changes to this by emitting this event every time that happens. So this is it. This is our full contract coin .solidity. This is how you implement a bare minimum coin. Let's go ahead now and just do a quick Brownie compile. So this is something you learned before. So it's just Brownie compile. It's going to go ahead. Now it says project has been compiled. Build artifacts is safe. So if you look into your folder, you should see that now you have something in the build. Within build, if you click on the contracts, you should see now there's a coin.json. So it's been compiled. What you've written here has been compiled successfully by Brownie. Okay, and if we go back into the deploy.py, now this is a good time for you to sort of change that, and I like to maybe put this after coin. So change the coin, and here is where you can change that and say, this is simple storage. So let's have a coin, and that would be just coin.deploy, and again the same idea. You can say from. So you need to when you deploy a contract, you need to incur some gas fee. So which account would that be? You need to specify an account so that the gas fee can be deducted from that, right? You need to pay a gas fee to deploy this onto the blockchain. So we're gonna just say account. We're gonna take the first one as well, so just 0. Okay, this is something we learned before. We probably don't need the print statement anymore, so just gonna remove that. And now if you go back to your terminal, you can go ahead and just do a Brownie, and you can do a run scripts deploy.py. And if you run that successfully, you see that both contracts has been deployed. First of all, simple storage is deployed at this address, and then transaction is deployed at this address. Okay, so simple storage is deployed at this address. Just copy that. It's going to be deployed this is always going to change, so don't even paste it somewhere. The reason I'm pasting this here is to later show you how it looks like in Ganache, just to remind you how it works. But you don't have to, this is not going to be a hard fixed address because you're not actually deploying to a real blockchain, you're just deploying that to your local blockchain. So let's just paste it in here. Now what I want you to do is to pause the video a little bit and see if you can still remember how to go through the workflow that you've learned before. Opening up Ganache, check whether this is, whether this is the address and whether you see that. And if you've done that successfully, come back to the video, resume from the video. I'll give you 1 minute to do that, and then I'm going to show you how to do that. Okay, so we have Ganache open now. So if you haven't figured out how to do that, now we're going to just hit on quick start. Notice that right now we have nothing in the transactions, no contracts, no transactions, no blocks. But what we're going to do is we're going to go ahead, run the script again. Now that we've Ganache open, it's going to attach to Ganache. And now if you go into Ganache, you can see that blocks. Now there is the first one and then there's the second one. And what happened? There's a transaction in here. If you click on the transaction, it says contract creation. So if you look at the block number 2, that's also a contract creation. Now why are there 2 transactions? Because we deployed 2 contracts. And if you click on the transactions, you can see the 2 contracts, and you can compare the transaction hash to confirm that that is in fact what you see within the Visual Studio Code within your Brownie itself. So if I look at the first one is BE05, and if you compare that to what you see right here, so BE05, you see that BE05, and if you compare that to Ganache, you see exactly the same one, BE05, right up here. And if you do the same thing for the second one, close Ganache, you see that the other one here is deployed, and that is the transaction 32C5. Okay. And so if you compare that to Ganache, you see that there's also the same thing, 32C5. Okay, so this is the transaction. So every time you want to do something on the blockchain, you send a transaction, right? Unless you just want to read some values off the blockchain. You want to do a view function, for example, that's just going to read a value of that. You're not actually going to send this transaction. But if you want to create a contract, you want to create a variable, you want to modify a variable, you want to do anything like that, you're actually going to create a transaction. So these are the transactions that say that that has happened. Okay, so what is the type of the transaction? That's a creation. You look at the contract creation, that's the type of the transaction that you're making. Okay, but the transaction is just a transaction. It's not where your contract is residing, where is it sitting on the blockchain. That's something that you're going to find out from contracts itself. So let's click into contracts. We don't really have that now yet because we haven't linked that, but you will be able to see the created contract address from here anyway. So let's click on that. This is the contract address. Okay, so you have 1D F77. And if you close this out and you look at this one here, you see that the contract is deployed 1DF77. So exactly here, it's exactly the same. All right. And if you look at the other one, let's go back to this one and BE. Let's click on this one instead. Now this is the contract address 1DF64. Okay, 1DF64. If you close that one out and you compare that to this, you're gonna see 1DF64. All right. So this is telling you that now you have 2 contracts. You send 2 transactions. The first transaction is here. Then the second transaction is here. This is how much gas you've used here. This is how much gas you've used. This is how much gas you've used to deploy another contract. If you write a contract that has a lot of things in the constructor and doing all kind of things, a for loop, doing some kind of crazy transaction, sending out transactions to everyone, for example, that's going to cost you a lot more gas. In this case here, the gas is not a lot. This is all in Wei unit, by the way, not in Ether unit. So remember that one Ether is the same as 1 to the power of 10 to the power of 18. So that's a lot of Wei, right? And then here is saying that where did this deployed? Where is this contract deployed? And here is the address of that of where the contract is sitting on the blockchain. So this is it. So every other contract from now on, maybe your friend, maybe some other people, maybe some NFT marketplace, if they want to work with your contract, they want to inject some coins, they want to use your coin, they want to transact in your coins and stuff, this is where they're going to be, this is what they're going to actually be, where they're going to be sending it to, because this is where your contract is sitting. This is for the simple storage, this is for the coin. So this is the most recent one that we're sending, all right? So this is kind of the main idea of how you use that, and how do you use Ganache with Visual Studio Code. Nothing you don't learn already, but what you can also do is to look into the logs itself. And in the logs itself, you will see that, okay, first of all, it starts a server. It says that, okay, initially I'm going to set some default values. There's the gas limit, the gas price. There's a host name, all of this. and then it says Ganache started successfully. So if you get into any kind of problems, running into any error, and you want me to help you troubleshoot and stuff like that, you create an issue, make sure that you paste at least the logs here, so I can see, what's happening, what's not happening, and I can, other people can help you troubleshoot more effectively by just looking at the logs itself. But here, this is what's actually happening. It's saying that after all of this is done, you set up a, get transaction count, do all of this initialization, and then you send a transaction. Now, when you send a transaction, there are a few things that happen in here, right? It needs to first record the block time, block number, gas usage, contract sent. So it gets that. Once that's done, it does the second one. Now, again, it sends another transaction. Why? Because we have two contracts to deploy. One is the simple storage, one is the coin. So it does all of this. So this is kind of what's happening in the log. And if we continue to transact here and we continue to run some scripts to send some transfer and stuff, then we can see more transactions piling up. So right now, if you want to sort of give it a try, you can go ahead and make some transaction. You can create you want to deploy the two contracts, and then you want to set a value directly from simple storage. Remember, in simple storage, we have a way to set a value. So that's kind of what we want to do here, right? So let's go ahead and actually just abstract out the accounts 0. Let's make sure that we take that out, and we just gonna create admin, and we say the first account belongs to admin, so that now we can just go ahead and just copy this and paste it everywhere. Same thing in here. We don't need that anymore. Just say admin like this. And now we want to just go ahead and perform a contract call. Okay, so perform a contract call. And in here, we're going to just say SS. And remember, in simple storage, we have the set and get function. So let's go ahead and say set. And we want to set the value to 7. And then we want to say set, and we want to say get value after that. Now, because get is just a view function, we don't actually need to send a transaction. So we don't really need the from admin. But set is a transaction. Okay, this is a transaction, meaning somebody have to pay something. Somebody have to pay a gas fee. All right. So because of that, we're gonna have a from admin. So let's do that. So it says, okay, you need to take some gas from us. You need to charge us, some gas fee. Fine, charge it from this account, the first account. Okay. So let's do that, and let's go ahead and run it now. Brownie run scripts deploy.py. Okay, it says, first of all, send a first transaction to create the simple storage, and then send another transaction to create the coin contract, and then send another transaction. But this time, notice that there is no constructor. Why? Because there is a constructor here, there's a constructor here, because we're calling a constructor on when the contract was first created. But in here, we don't have a constructor because we're not doing any kind of contract initialization. We're not doing any kind of contract creation. We're only trying to transact using a contract call here. But notice also that the first one here incurs some gas fee, here incurs some gas fee, and here also incurs some gas fee. But you can compare the gas fee, and you can see that the gas here is a lot cheaper. This is a much cheaper transaction than these two. This is only 32,000 Wei. This is 233,000 Wei, and this is 226,000 Wei. So this is a much cheaper transaction, but you see that that has happened. So if you now go back into Ganache, you will see that there is now two contract creation, and now there's a contract call. So if you look at the contract creation here, it says that this is the coin contract, this is the coin contract, this is a simple storage contract, and in the simple storage contract, if you look at the created contract address, that's 961B37. If you go back, you can compare this to this address, and it's exactly the same. So this address here, 961B37, is exactly the same here. So these two are contract creation, but this is just a contract call. What is a contract call? Now that contract call is just a event that we just perform to set the value. Okay, so remember there is only 3 transactions here. You're saying that how come get is not another contract call? Well, because get is really just a view function. So if you compare that to our transaction here, so this is the first transaction, second transaction, and then this is the third transaction. This is not a transaction, and the big giveaway is that there is no from admin, but also because it's a view function, we don't have to incur any cost, right? So that's how you know. And here you set a value of 7, and this is a much cheaper transaction than these two. These two are more expensive transactions, and you know that by looking at the gas use here. Okay, so gas use is something that you want to pay attention to when you're starting to create all these contracts. And if you then look at the blocks itself, you see that now you created more, all of this transaction created a new block. And then if you look at accounts itself, still it's 100, but you see that now there is 8 transactions by the first account. Yours is going to be 5, I think. I just did another one, but I realized that it wasn't recorded on video, so there was something that bugs out. So I re-record that part, and now it's I added 3 to it. But don't don't pay attention to that. You should be able to see like 5 at least here, right? And then there's the logs here, and you can see what's happening in here. You can compare the the transaction logs, and you can see what exactly happened. Scroll all the way to the bottom. You see that here you're setting the value, and here's you setting the transaction, and that's kind of it. Because I'm recording all of this in Indonesia, you see that the block time would be in Western Indonesian time, so Ganache is actually also smart enough to do that for you. But you can see this is a transaction count. Now it's incremented, and you can see the blocks, you can see transactions, and that's kind of how you do it in Ganache. And we haven't really used the contracts yet, but I think this should do it for now. So that's it for part 2 of the series. I hope you enjoy. Today what we did was we did a summary of what we learned in part 1 of the series, and then what we did was we also implement a very simple form of cryptocurrency. This is your own currency, and it allows the creator to create new coins. We create a minting function. So in the next video, we're going to try and play around with that and do a revision as well. And then we're going to go into the coin function and start to play with that, interact with that. How do we mint new coins, right? You can find other ways to implement new issuance schemes. So issuance schemes is kind of a way for you to disperse the first circulation of your coins, so that it's in the economy. Anyone can send coins to other after you do this minting function, right? And we also see how you can create a send function that allows people to transact without actually having to create an account, like a username and a password in the old world. In the decentralized world, all you need is an Ethereum address, which is a key pair. So you don't need to create a username. You don't have to have this central authority to manage all of these transactions. You can actually have this. Anyone can send coins to almost anyone else, right? And so this is kind of the what we just implemented. So a lot of these new concepts, because they're so new to you, in the next video, what we're gonna do is we're just gonna go through them again, just refresh the same ideas, do a quick revision before we go into the next part, of part 3. And that's all I have today. Thank you. See you again.